My name is Ng Yang Jing and my metric number is 01DAD23F2001. Now let's look at the introduction and objective. In the automotive industry, aerodynamics play a crucial role in determining a vehicle's speed, stability, and fuel efficiency. One of the key parameters used to evaluate aerodynamic performance is the drag coefficient, which measures the level of air resistance a vehicle encounters while in motion. This study aimed to compare the aerodynamic performance of several car models, including the Mazda 3 Liftback, Subaru WRX, and Ford Ranger Raptor. This comparison focused on the dimension of each vehicle, especially length and weight, as well as their respectively drag coefficient value. Through this analysis, it is possible to understand how differences in the vehicle design and shape influence their ability to move efficiently through the air. Now let's look at the objective. The objective of this project is to identify and compare the basic specification, length and weight of selected vehicle model. 2. To analyze and compare the drag coefficient of each vehicle. 3. To examine how the shape and size of a car influence its aerodynamic performance. 4. To propose improvement of vehicle design to achieve better aerodynamic effection in the future. So now we look at the specification. This table is about the list of dimensions of each vehicle model. So now we have the model of vehicle, length and weight. Now let's look at the first model of vehicle, which is the Mazda 3 Liftback. Its length is 1.46. The length is 4.46 meter and the weight is 1.79 meter. So next we can look at the Subaru WRX. Its length is 4.67 meter and the weight is 1.825 meter. So we have the last one, the model of vehicle, which is the Ford Ranger Raptor. Its length is 5.381 meter. It's longer than those two vehicles. And its weight also is 2.2 meter, also longer than Mazda 3 Liftback and Subaru WRX. It's the longer one.
The calculation shows that the vehicle drag coefficient of three vehicle model, which is vehicle model A, Mazda 3, vehicle model B, Subaru WRX, and the vehicle model C, Ford Ranger Raptor. To calculate the drag coefficient, we need to find out the velocity, drag force, frontal area, air density to find out. All of the air density is 1.225 kg per meter cube for 3 model, and the velocity was 100 to 200 in every 10 meters per second change. For the vehicle model A, which is Mazda 3, it has 6.0043 meters square of frontal area. For the vehicle model B, which is Subaru WRX, it has 6.39 meters square of frontal area, and the last vehicle model C, which is Ford Ranger Raptor, we have the frontal area of 8.88. For the drag force, higher when the velocity is higher, the drag force will be higher, which means when the velocity was 100, the drag force will be 249.741 Newton, while when 200 velocity, it will be 998.963 Newton. So for the coefficient vehicle model A, to find out the drag coefficient of vehicle model A, which is 0.09. For the vehicle model B, the drag coefficient, which following the formula, will be 0.08. And the last vehicle model C, which is Ford Ranger Raptor, the drag coefficient will be 0.06. For the conclusion of calculations, every vehicle model have same air density, same velocity, and same drag force. For different, three models have their different frontal area to find out the different drag coefficients. velocity from 100 to 200 and every 10 meters per second change, the drag force will be different, which is from 249.741 Newton to 200 meters per second with 998.963 Newton.
Now we have two graphs to compare the three cars. The first graph is drag coefficient versus velocity. We can see that the Mazda 3 liftback is higher than the other car. The second one is Subaru WRX, and the third one is Ford Ranger Raptor. The second graph is drag force versus velocity. Aerodynamic drag is calculated using the formula Ft equal to 1.5 multiply P multiply CD multiply A multiply V power 2, where Vd is drag force, P is air density, CD is drag coefficient, A is frontal area, and V is velocity. The baseline drag calculation is Vd equal to 1.5 multiply 1.225 multiply 0.34 multiply 6.1725 and multiply 30 power 2, and the final Vd Ft is 1157.6 Nm. Proposed modification: first one is front splitter. Function is reduce air flowing under the car and improve airflow direction. The effect is reduce turbulence under the car, improve airflow attachment, slight reduction in CDs. The improved drag calculation after the modification assume CD 0.34 to 0.30, and all the calculation we can count out the final FD is 1021.8 Nm. This is the comparison of the original and the modified drag force. We can see that after modifying, we can reduce about the 135.8 Nm drag force. The aerodynamic modification such as the front splitter, rear spoiler, flat underbody, side skirt and rear diffuser significantly improve airflow around the car. These upgrades reduce the drag coefficient and overall drag force, resulting in better fuel efficiency, improved stability and enhanced vehicle performance.
Hello dan selamat sejahtera kepada tuan dan rakan-rakan saya. Nama saya Joel Christopher, nombor kad matrik 01DAD23F1082. So sekarang saya akan membincangkan tentang result and discussion tentang presentation kita. So untuk result dan discussion, based on the data collected, each vehicle model exhibit different drag coefficient value to the variation in body shape, size and overall design. The Mazda 3 liftback records the lowest drag coefficient among the three vehicles, indicating superior aerodynamic performance. This allows the vehicle to move more smoothly through the air with reduced resistance, contributing for better fuel efficiency. The Subaru WRX shows a moderate drag coefficient as its design balance aerodynamic efficiency with performance and stability. Its sporty structure and added aerodynamic feature improve handling but slightly increase air resistance compared to more streamlined vehicles. In contrast, the Ford Ranger Raptor has the highest drag coefficient due to its larger body dimension and off-road oriented design. Its body shape and higher ground clearance result in increased air resistance, reducing aerodynamic efficiency. Based on the finding of this study, the shape and size of a vehicle significantly influence its aerodynamic performance. More compact and streamlined design such as Mazda 3 liftback tend to achieve lower drag and better efficiency compared to larger, less aerodynamic vehicle like pickup truck. So seperti yang anda boleh faham, kalau design kereta tu lebih smooth seperti Mazda 3, drag coefficient dia rendah. Dan jika kenderaan tu seperti segi empat design dia macam Ford Raptor atau biasa kita tengok bus atau lori ya, bila dia tak boleh pick up kelajuan dengan cepat sebab drag resistance dia sangat tinggi, sebab dia tak ada shape ke depan dan dia berbentuk seperti sebuah kotak. So next saya akan buat conclusion dan reference. Sekian. Okey, sekarang untuk conclusion dan reference. In conclusion, each vehicle demonstrates different levels of aerodynamic performance influenced by its size and design characteristics. The Mazda 3 liftback achieved the best aerodynamic efficiency due to its compact and streamlined body shape. The Subaru WRX shows moderate performance and it's designed to balance aerodynamic efficiency with sport performance and stability. In contrast, the Ford Ranger Raptor records its highest drag coefficient mainly due to its larger body size and off-road oriented design. This study highlights that factors such as vehicle shape, height, and surface design significantly affect air resistance. Vehicle with lower drag coefficient can move more efficiently through the air, resulting in improved fuel economy and better high-speed performance. Therefore, understanding aerodynamics principles is important for engineers to design vehicles that are not only efficient and high-performing, but also safer and more environmentally friendly. So secara ringkasnya, kalau drag coefficient sebuah kereta tu lebih rendah, ia akan lebih fuel efficient atau jimat minyak. Kalau kereta tu seperti Ford Ranger Raptor yang mainly fokus untuk off-road dan sebagainya, ia akan makan minyak lebih lah sebab design body dia yang berpetak dan drag coefficientnya yang tinggi sebab design dia. So ini design Ford Ranger Raptor dan ini airflow. So bila dia kena, ia akan slow down kereta tu. Kalau kereta Mazda 3 design depan dia macam ni, so dia lebih smooth. So yeah, thank you. I hope you all understand our presentation. Terima kasih kepada semua yang menonton.
What is a car's drag coefficient? The drag coefficient of a car refers to the amount of air resistance the vehicle encounters while driving. Generally, the lower the drag coefficient, the less fuel the vehicle consumes during travel. This is because, at a speed of 50 miles per hour, 80 kilometers per hour, 60% of the car's power is used to overcome air resistance. Under the same conditions, if a fuel-powered car reduces its drag coefficient by 10%, it can lower fuel consumption by about 3%.